This is Math 60, section 4.3, the fourth page of the nonstop fun fest that is absolute value inequalities. I mean, really, is there any more fun to have? So much fun. I don't know if you can hear it. My bunny is ringing his bell. This is just a party all the time. So, shall we approach this one? Woohoo. Dun, 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 dun. Okay, I've got 4x plus 2 inside an absolute value, and it has to be greater than 6. So in other words, I want whatever ends up happening in here, I take the absolute value, I end up bigger than 6. So in other words, this is going to be an outside one rather than an inside one. Okay, so first thing I do, I think last time I only had one step. I forgot to write step 2 on it. Oh, no. Okay, I'm cheating. I added a step 2 that you can't even see, but you'll see it in the notes. I'll try to remember to do step 2 here. So step 1, solve the related equation. So let's solve the absolute value equation. So if I've got absolute value, something equals a number, either the thing equaled the number without the absolute values, or the expression, look at me using real math terms, expression. I know you're paying for the big words, so I'll use them. 4x plus 2 equals -6. So either it equals +6 or -6. I subtract 2, da-de-da. 4x equals 4, so x equals 1. The sun is shining. That's a lie. It's totally raining right now. But the sun is shining on our math. Life is good. Subtract 2, subtract 2. 4x equals -8. This never turns out this well. Be afraid whenever things go this well in math. But okay, I got x equals 1, x equals -2. And again, I'm going to find these both on a graph. You know what? I feel bad that I've been skipping 0 all these times. So let me go ahead and there's 1. It's because I have no perspective on spacing, but closer, sorta. Okay, so there's x equals 1, and there's x equals -2. So that was step 1. We found these endpoints. And now we go back to the original problem, which you can see right up here. And in fact, I will shrink this down ever so slightly so you can see more. Ooh, I know it's fancy. I've got all the tools. I want to look for numbers which are strictly greater than 6. I want values after absolute value, they're greater than 6. So that means I want to stay on the outside, not on the inside. I want to go to the outside. So I'm going to go to the outside of 1. And I'm going to go to the outside of -2. So this is step 2. Now, you might ask, why are there parentheses? Why not brackets? And the answer is because this was a strict greater than, not a greater than or equal to. If it had been greater than or equal to, it would have been the brackets. So if I wanted, so now that we've got this written, we can go bonkers. I could say 4x plus 2 is greater than or equal to 6 would be the same graph, but with brackets at -2 and 1. I could say 4x plus 2 absolute value is less than or equal to 6, and that would be this. I could say, look at me coming up with all the related ones. I could say absolute value of 4x plus 2 is, and that would be this bad boy. What do you think? Woohoo! The key to doing these problems is coming up with these boundary points, the edge points, and knowing whether you're going to stay to the outside because you're larger than, or to the inside, so stay small for the smaller than ones. These two stay in the middle, these two stay to the outside. Woohoo, you made it. You survived the Thunderdome. We survived absolute value inequalities. You can use this to scare your family and friends. Save it up for Halloween. Dress up as an absolute value inequality. It's fun for all ages. And I will see you later with chapter 5. Woohoo.